Hello, everyone. Welcome back. So, today we're going to be talking about the volume of a cone and also the volume of a sphere. So, those are our topics for today. So, let's start with the volume of a sphere. So, here's an example of what we mean by volume. We mean how much, um, you know, how much space is taken up by a sphere or by a cone, or how much water or how much of another liquid or material could we put in to here, some sort of liquid material that will actually fill up the entire space. So the city water shortage tank, which is located at Sherbrooke Street West, is in the shape of a sphere. If we are asked to find the volume of water that the storage tank can hold, we must use the volume formula. V equals 4 over 3 pi r squared, pi r cubed. Okay, so the volume formula, this is very important, is 4 over 3 pi r cubed. So let's use that to find the volume of the sphere below. So for this one, what we would do is we're going to say volume is equal to 4 over 3 pi r cubed. In this case, r is 3, so this would be 4 over 3 pi 3 cubed. And let's see, well, 3 cubed is going to be 27. So this is going to be 27 times 4 over 3 pi, which that is going to be 36 pi, which is, let's grab our calculator and grab a good estimate on that. So 36 pi is about 113.1 centimeters cubed. And keep in mind, in this case, it's cubic centimeters, right? Not square centimeters, because we're taking a look in this case at an entire volume, right? So we want the full that full volume with all three dimensions, not two dimensions. Okay. Now let's take a look at example 2. It says in this case, the diameter of the water storage tank is 10. Calculate the volume. So what we must do first, before we can actually calculate the volume, is we must find the radius. So remember, radius is equal to the diameter over 2. In this case, the diameter is 10, so therefore the radius would be 5 meters, or half of that. So therefore, the volume is going to be 4 over 3 pi 5 cubed, which is equal to, well, 5 cubed is 125 times 4, divide by 3, is going to give us 166.67 pi, which is about 523.6 meters cubed. And there we go. Okay. Next, let's move on to the volume of a cone. So when calculating the volume of a cone, it might be helpful to know that a cylinder holds exactly 3 times the volume of a cone when they have the same height and radius. So the volume of a cylinder is pi r squared h, right? Because it's the area of the base times the height of a cylinder. A cylinder is like a can shape, so if you can picture like a can. Whereas a cone is going to be pi r squared h divided by 3, because a cone only holds a third of what a cylinder with the same height and radius actually holds. So here we have example 1, and it says that a cylinder with height 4 and radius 10 has a volume of 1,256 meters squared. What is the volume of a cone with those same dimensions? So for this one, we don't actually need to know the dimensions. All we need to know is that the cylinder with the same height and the same radius is 1,256 meters cubed. So all we must do is divide this by 3 to get the answer for a cone. So let's grab our calculator again. 1,256 divided by 3 is going to be 418.6 0.67 approximately meters cubed. So therefore, the volume of the cone is 418.67 meters cubed. Very good. Okay, then here it says calculate the volume of the waffle cone from an ice cream store. All right, so for this one, remember it's going to the volume equation is going to be pi r squared h over 3. So in this case, r is 3.5 and h is 9. So let's find the volume based on that. So what's 3.5 squared? 12.25 times 9, and then divide that by 3, and we get 36.75 pi, which is approximately going to be 115.45 centimeters cubed. And there we go. All right, let's do the same thing for our next question here, which asks us to calculate the volume of this cone. So how do we do that? Well, same as before. Volume is equal to pi r squared h over 3. In this case, our radius is 12, and our height is, this is the slant height. This isn't the actual height. So what must we do to find the actual height? We need to use Pythagoras' theorem to find the actual height. So the height squared is equal to 20 squared minus 12 squared by Pythagoras' theorem. Again, if Pythagoras' theorem is a new concept for you, do make sure you go watch the lesson about that, because that's a whole separate topic that was covered previously, but it will come up in this course as well. So do make sure that you go check that out if that's something you're unfamiliar with. But basically, Pythagoras' theorem states that whenever we have a right angle triangle, that if we add up the squares of the two legs of that right angle triangle, then that will give us the square of the hypotenuse, right? That's essentially what Pythagoras' theorem is, or you may also know it as a squared plus b squared equals c squared. Good. So h squared is going to be 400 minus 144. And then let's take the square root of that, and we get 16, right? So h squared is equal to 256. And if we take the square root of 256, we get 16. So therefore, our height is 16 meters. So now we can continue with our original equation by plugging in our height and continue. So then here, if we simplify this, we get 768 pi, and that's approximately going to be 2,412.7 meters cubed. And there we go. Awesome. All right, so that is everything for today. Today we pretty much just went over the volume of a sphere and the volume of a cone. So definitely take note of those formulas and make sure you're able to apply and use the formulas. And the biggest thing to remember is to make sure we are using the correct dimensions, because the biggest mistake I would see, especially for something like example 2, would be someone saying, oh, we have 12 and we have 20, so just assuming, oh, well, 20, that's the height. 20 is not the height here, 20 is the slant height, and so it's crucial that we use Pythagoras to get the actual height, otherwise we're going to get an incorrect answer. Okay, so do keep that in mind to make sure that the dimensions you're plugging in when you see your visuals are the correct dimensions, because you may have to find something like, like the height in this case, using Pythagoras or some other technique like that in order to solve this. So definitely make sure you do that, and that's all. Good work, everyone, and we'll see you next day. Bye, everyone.